Okay, I think we can get started. Welcome to building a Kotlin Multiplatform Library in 10 minutes. Why not? So before we get started, I do need to give a viewer discretion. There will be live code generation ahead. This is quite a scary topic, I know, so if you are of the faint-hearted, please feel free to leave now. That is your only warning. Before we actually get started, my name is Zachary Powell. I've been an Android developer since the dawn of time, or 2009. I transitioned into developer relations and developer experience a few years ago as an Android developer advocate, and I've now turned to the dark side and manage a team of developer advocates at Vonage. And you can find me everywhere as Dev with Zachary. I'm all over the internet. So a brief slide about Vonage, as they have paid for my expenses to be here. Basically, Vonage does communication APIs, things like voice, video, SMS as an API. They also, through being purchased by Ericsson, have now started a new range of APIs called network APIs, which leverage 5G networks to do cool stuff. But that's not what we're here to talk about. If you are interested in that, please do go Google it. What we're here to talk about. As software developers, we interact with a lot of different libraries. These libraries take lots of different forms. They might be in the form of massive framework SDKs. For me personally, that would be the Android SDK that exposes all the things about Android on top of a JVM. It might be things like Node.js or whatever else it might be, these massive kind of frameworks that try to make things easier for developers. You might use some sort of frameworks when it comes to testing, things like unit test libraries and that sort of thing. You're almost certainly going to be using some sort of library there because it makes life a lot easier. You might also, if you have to do dependency injection, you're probably going to use a library. Doing that yourself is no fun. Just use a library. Networking. No one likes to make raw HTTP requests. Let's just use a library and make that a lot easier. And many, many, many more. Point is, we use a lot of libraries. We also interface a lot with application programming interfaces, or APIs. These might take the form of third-party APIs. So things like separate services from another company that you might integrate into your own application, perhaps, for example, to get data about the weather or any other sort of data, or maybe it's to actually add some sort of functionality into your application. Maybe you need to add video calling into your application, and you're going to offload that to another company. Either way, it's kind of the group, a bucket of third-party APIs that you have no control over, you're just consuming them. The other type of APIs that you will probably interact with are internal ones that have been built by teams within your own company, maybe another service within the company that you need to access. Perhaps you are working on the back end and you're building an API for a client to consume. So it needs to be able to expose different data models and all those sorts of things. And those are the kinds of APIs where you're going to have probably more control or at least more input into how they look, what they do, what you receive, whether you're actually building them yourself or someone else in the company is doing it. And no matter what the APIs are, manually consuming them is no fun at all. If they lack libraries, as we've already said, doing things like consuming raw HTTP requests is painful work, it's slow, it's a lot of boilerplate stuff, it's boring. It may be missing documentation. Now, in my experience, this is particularly true when it's an internal API that was written 10 years ago by someone that's no longer at the company. No one actually knows how it works. It's just when it's working, it's fine, and you don't touch it. So you don't have that documentation. You don't have that ability to understand, well, what are the error cases? What are the different inputs that that API might expect? What are the different things it can return? You might only know the happy cases that have already been used somewhere else in the company. So all of that can be very time-consuming. It can be very difficult to work with. You can end up spending so many hours working on something that really should be done for you. It shouldn't be so painful. It also leads a lot of ambiguity. Again, you might think you've got it all right, but without that documentation, you don't know, especially if it is an external third-party API, so you can't even look at the source code to try and decipher it. And even then, actually being able to look at the source code isn't necessarily helpful a lot of the time. So let's fix that. I wonder if you can guess how. By generating libraries. Woo. So we are looking at something called OpenAPI and the OpenAPI initiative. No, this is not the OpenAI initiative. And if I say OpenAI at any point, please stop me. No, we're talking about the OpenAPI initiative. So, show of hands, bit of audience participation. Who has heard of OpenAPI? Brilliant. We're done then. No, that is brilliant. That is brilliant. Who uses OpenAPI? Okay, this is great. This is great. It makes my job a little bit easier. And for the rest of you, hopefully you learn something new and you start using it. So, what is OpenAPI? As I've just said the same. I'm going to say OpenAPI a lot in this talk. I apologize in advance. Nonetheless, what is it? Well, from the Swagger website, it's this group of words. But essentially what it is a way of defining an API in a manner that's completely language agnostic for HTTP APIs. And it is human readable, but also machine readable. So you're creating a document that can do both. And basically, that can be your root kind of truth about this API. So you do this through OpenAPI documents. And OpenAPI documents are define objects that break down your API definition. These objects might include things like metadata, so things like who wrote the API, when was the API last updated, what's the version of the API, what's the license attached to the API if there is one, all these sorts of things. Server information, where do you need to point to use that API? Kind of critical information. The different endpoints that make up that API. Okay, you know where you're pointing to, so now you know what are the different parts, things that you can actually hit and what they do. And then, of course, the information that you're going to send to those endpoints and or the information that is going to be received back from those endpoints. And it can be done and defined in kind of two formats. We have JSON, which, as far as I'm concerned, is the more sane method. And this is just an example of some metadata for a fictitious API. Or, of course, if you do hate yourself, you can use YAML instead. And again, same for, it's just a different way of formatting it. Personally, I hate it, but it's there. And the great thing is both are supported. So if, for example, you work in a company where you don't have control over which can be consumed by your application, well, both are supported. So there you go. But why? Why would you want to do this? Why would you want to put the extra effort into writing an API spec? Well, fundamentally, the biggest thing that doing this will do is create an API contract between those that are building the API and those that are consuming it. Both parties will understand exactly what is expected from that API. Those consuming the API do not care how the API has been written. They do not care what fancy programming languages have been used to do it. They just care what is being taken out, what is being returned to them from that API. And vice versa, those that are building the API don't really care what's being done with that information once it's been exposed, just that it is being exposed in that way. So outside of that very critical creation of a contract, which I think on its own is massive justification to do this, there's other advantages, particularly when you are using a standard. You could, of course, come up with your own API contract, your own API specification in your own format that's only used in your own company, and you could do that, and they would still benefit some of it. But there's lots of other benefits to be had when you use an open specification that is open sourced and available to everyone. And one of the big things is the tooling. If you start using OpenAPI specification or an open specification, there are tools available to you that will automatically generate your documentation. They will take in that spec, and they will create a nice fancy web page for you that gives you all the breakdown for a developer to understand that API. No work done, and also it can be automated. So you make a change to that specification, the website updates. Mocking. There are lots of really great mock tools available, which mean that if you are the client side that is trying to consume that API, but that API doesn't actually exist yet, you don't have to wait for the developers to develop the API before you can start implementing it. You can use the OpenAPI spec as your mock, you can build mock objects, and you can start building your client side from that. So especially if you are like internally as a company building both the back end and the client side, you can suddenly work in parallel. You haven't got to wait for the API to exist for the client to be created. Security. There's also some really great security tools that will automate things like auditing your API. They can take in your API spec, they can compare it to what's actually live in production, and they can do testing against it, they can pen test it, they can do all the other sorts of security. I'm not a security expert, but they can do those things, and essentially the API spec works as a map for them. And again, it's just another way to automate and speed up processes. And then testing, alongside mocking, just generally testing. On the back end, you can write all your unit tests. You can do test-driven development when building your API, because you know what it's going to look like. You've got the spec. Build out your testing suite, and then start building the API to match that. And then, while we're here, code generation. There are some really cool tools that will take the API spec and build libraries from it. And there's a website called it's quite small here, but it's called openapi.tools that kind of gives you a huge list of all the different tools in all the different kind of categories that we've spoken about that use or can consume OpenAPI specs. So it's a great place to go to. It's not affiliated with the OpenAPI initiative, confusingly, but it is a nice big list of stuff that you can do. So we need an API to test this out with. And thankfully, I know a company that does APIs because I work for them. So we're going to take the Vonage SMS API because it's kind of the simplest API that we have. Basically, it's just an endpoint you can send stuff to, and it sends it out as a text message. So we're going to use that in our example. And what would you know? We also use OpenAPI specs. So all our APIs have OpenAPI specs. Here is a snippet from the SMS API, which is kind of outlining some of the information about the post endpoint for sending an SMS, and it starts listing the parameters. There's a lot more than that, but it's there. So the tool we're going to use is called OpenAPI Generator. Again, not affiliated with OpenAPI Initiative. It's a third-party open source tool, but it's very cool. So if you want to go check out, that's the website, openapi-generator.tech. And the great thing about this tool is it supports a huge range of languages and frameworks. So on the server side, there's this lot. I'm obviously not going to go through them all, but you've got lots of different Go servers with different frameworks, mainly around the HTTP bit, lots of different Java frameworks, lots of different Kotlin frameworks, Node, Python, all that sort of stuff. There's loads and loads of different frameworks supported. It also supports a lot of clients. So you can build client side to this as well if you need to. And as a primarily client-side developer, that's exactly what we're doing here. We're going to take the Kotlin client, specifically because the Kotlin client supports Kotlin Multiplatform, which in itself can then also be run on the server side. So it all gets a bit confusing. But the point is, it generates a library that can kind of run everywhere. So to do so, you download the OpenAPI Generator tool. Again, that is in itself available in lots of different formats. I think it's a Node package. It's other stuff. But I'm a Java developer, so I'm going to get the jar and use it from the command line. So this is kind of going to be what the command ends up looking like. First off, we call the jar and use the command generate, because that's what we're doing. We pass in our OpenAPI spec. We tell it which generator to use, in this respect, just Kotlin. And then we can pass in, oh, that's gone. Okay. We can pass in some additional properties. In our case, these are going to be different from generator to generator, but in our case, we're telling it, use the multi-platform library, and for the date library, use Kotlin X datetime, because that's the one that's supported through Kotlin Multiplatform. But if you were building something specific for one, for like just for Android or just for server, you could use different libraries. So let's do it. Let's see if it works. So here we go. We have our command all nicely pre-laid out. So we're going to hit enter, and it's going to do a load of stuff. It's going to give us some information. It is going to complain about some stuff as well, most likely. But the point is, it has now generated, and then also it gives you a nice consider donating if you want to. I'm not affiliated with this in any way, by the way. I just use it. So that's the code generated. But what did it actually generate? This is our generated SDK. So the first thing I am going to do before I forget is we're just going to change the Kotlin version, because the generator is still using Kotlin 1.9, and Kotlin 1 is dead to me. So we are only using Kotlin 2 here. That's the only thing I need to really change. And if you kind of understand Java, Kotlin, that sort of world, we have a fair amount that has been built for us. We have the API itself. Again, it's called default API, but you can pass in parameters to name everything whatever you want. It does all the kind of constructors for us, all the different kind of enums and classes and everything else we need. It handles all the different authentication that we might need, API key auth, HTTP basic auth, OAuth, all that sort of fun stuff. And it also gives us all our data models and everything else. It also kind of handedly gives us a bunch of kind of generated documentation as well. So we're getting a little bit of documentation for free. And it gives us information about what the endpoints can do, gives us some example code with unfortunately, it has very long comments against each parameter, and there's lots of parameters in this example. So it's a bit of a mess, but it's giving it us for free. Again, it's not the best, but it is all there. So let's try and actually use this generated library. So we can head over into a Kotlin Multiplatform project that I already have set up, a very simple compose app. Here we're just going to import the SDK as a project into this project, and then it's pretty straightforward. We just have our app. It doesn't matter if you don't do compose at all. It's fairly straightforward. Essentially, we're going to show some text on the screen. That text is either going to be the response of us sending a text message, or the response of the send SMS method, or it's going to show an error if anything goes wrong, which is, it's live, so it's possible. And then in our SMS class, this is literally the example that they gave us automatically generated, and then I've just filled in some of the values. So we've got the text that we're going to send, which is basically just going to say, hello, Devworld, sent from, and the platform that it's being sent from. And then we're passing in our API key, API secret, to and from phone numbers. And that's it. So let's see if this works. And so if I run this, okay, and we go over here, there we go. So that did just spin up on the emulator side, and then this is my phone. Let's see if I get the text message. Of course, iOS notifications and the fact that I'm here and not in the UK. We'll see. Fingers crossed. Well, we'll pretend that happened. The point is, it should have sent a text message saying, hello from Devworld, sent from Android 34. And it would have worked, trust me. It does work. Thank you. So we'll gloss over that, but the code did execute. Everything was happy because there was no errors displayed. It's just physically the text message hasn't arrived on my phone. So before we go any further, I'd like to take a quick photo, if that's all right. If you don't want to be in the photo, hide your face. We're doing a quick selfie. Okay. Thank you for humoring me. Okay, onwards. So, we've talked about why we would want to do that and the advantages of doing it. Why should we not do it? And this is my attempt at a why not meme. It's the why meme, and then it's inverted, so it's not. Thank you. So why shouldn't we do this? Well, one of the issues is that incomplete/complex API specs may not generate as expected. There are lots of different versions of the OpenAPI spec. There are different things that you can do and implement in slightly different ways. Different generators within that tool don't accept all the different possible things that you can do. So the reason why we went with the SMS API is because it was one of the ones that worked flawlessly for a demo, other than the actual sending bit. But yeah, so there is an issue there where a lot of the time it won't necessarily generate completely smoothly or as you would expect. The other big issue is when it comes to generating a library, it's just generating a one-to-one mapping of your API spec. It's just generating, here are all the endpoints in the API. Here are all the parameters of that API. As you kind of saw from the example here, there was an awful lot of parameters that it required, but we just passed in as null. Because in our actual use case, we didn't need those parameters. They weren't used, but in the API spec, they're listed as required. So there's that. There's also the fact that there are lots of things that we do in APIs that don't require just one endpoint. There'll often be multiple steps that we go through to complete a task. And really, a library should bring those steps together into one concise step for the developer. It should make it as easy as possible to do whatever the task is. Again, the one-to-one mapping doesn't do that. You still have to go through every step. It's really just wrapping the HTTP calls. It's not doing anything more, which is kind of a pretty rubbish library, to be honest. So yeah, so there's no business logic. There's no, what do I actually do with this? What of this information does the developer actually care about? There's no helper functions. There's nothing to kind of make consuming that API easier. If you were happy with just consuming raw HTTP requests, well, you can kind of just do that, and you would be in the same place. But even though I wouldn't necessarily recommend just generating a library and shipping it, it can be a really great starting point. It can be a really great place to kind of just build all that boring boilerplate code and also kind of show to you just what the API spec has actually got in it. And therefore, you can start kind of applying that human logic to know what can be removed. We saw that example here, and we would know, oh, well, actually, OK, we probably need to overload that method and require way less parameters if we're in this specific use case. And it gets you thinking about the different kind of usability factors of your API. So it is fair to say that handmade SDKs are here to stay. If any of you are SDK library maintainers and you came here worried for your job future, I think you're safe for quite a while as yet. We're a long way off anything that doesn't require a lot of kind of massaging and hand-holding and building out. Like, obviously, you can automate it, but there's a lot of work to get you to that place. And someone's then got to maintain that. As soon as you make changes, you've then got to make changes to your system, and it just keeps going, really. So with that all in mind, I will say, do check out our Kotlin Server SDK. It's new. And if you are interested, you can get some 10 euros free credit as well and take a look at the SDK. It's also on GitHub if you want to poke around and judge it. I didn't write it, so judge all you like, and a colleague of mine will get the brunt of that. But thank you very much for watching. I hope it has been somewhat interesting. I hope it's kind of explained what OpenAPI is, maybe got you thinking about how you can use OpenAPI specifications in your own workflows. And yeah, thank you very much. If you would like to follow me, find me everywhere, scan the QR code, and this presentation is also available on GitHub. Thank you.